Welcome on this tutorial. In this video tutorial, we are going to discuss about 8051 microcontroller timer operation in mode 1. In this tutorial, we will learn what are the different functions of different bits in TMOD register, how to write the delay program using the timer. We will learn how timer works, at what condition the timer overflow will be high. We will learn how to generate square wave using the timer and CPL instruction. In this video tutorial, we will learn how to find the frequency of generated square wave. Now I am entering into the discussion. The last class and today's class also, we will use the timer, and the timer will be used in mode on operation. So for the case of mode on operation, just I am repeating a little. First thing, we should set the value of TMOD. Next, we should set the initial value of timer. Say we are using the timer 1, so T is 1. Next, we should set the value of timer lower bit. Next, what we should do, we should we should start the timer. So the instruction is set bit timer. Next, what we need to check whether the flag is on or off. So for that case, we should use the instruction J and B. Next, what is needed, we should make the timer off. We should use clear CLR, clear TR. Next, we should reset the timer flag TF. These are the basic instruction needed for creating the time delay or creating the square wave. So last class we have written a particular program, and that program was to create a square wave in a particular pin. So I am starting from the same problem. Say the problem is we need to write a program to generate a square wave at pin number P1.3. We should use the timer 1 in mode on, and frequency of the, and also we must find out the frequency of the generated wave, and we are using the crystal which is having the frequency 11.0598 megahertz. So what are the necessary things? First thing is that we must set the TMOD. For the case of TMOD, this is mode 1 and timer 1, higher level should be set. So for the TMOD register is having first bit is get, next bit is C/T, this is timer or counter, next bit is M1, next bit is M0, and this is for timer 1, and the similar 4 bit is for timer 0. So first 4 bit is for timer 1 and next 4 bit is for timer 0. As we are using the timer 1, so first 4 bit will be set. So gate will be 0 always, as we are using the software run. C/T we are using the timer, so this is 0, and this is mode 1. For the case of mode 1, this should be 0 1. This is the combination. We are not using timer 0, so this should be 0 0 0 and 0. And in hex, this is for the first 4 nibble, it is 1 and this is 0. So this is 1 0 in H. TMOD will be set as 1 0. So the instruction is move TMOD comma hash 10 H. So this is the first instruction. So move TMOD. This TMOD is the register which must be set with a particular value to indicate in which mode the timer is using. So here, according to this question, timer 1 in mode 1. So for the case of timer 1, the first 4 bits should be set, and for the case of mode 1, this M1 and M0 will be 0 1. Next, we must set the initial value of the timer. For the case of initial value of timer, now what should be the initial value of timer? In this question, nothing has been mentioned that what will be the exact frequency or what will be the time period. So we may use any value of T1. Say we are using 0 A1 2H. This is the initial value of the timer. This is the initial value of the timer. So the instruction will be this th1. th1, what is the value th1? th1 is the 0a. So the instruction will be move th1 comma hash 0a h. Next t1, what should be the value of t1? t1 will be move tl1 comma hash, the value is 1 to h. So this is the these two instruction, move th1 comma 0a and move tl1 comma 1 2. These two is for initialize the value. The next instruction or next part of this program will be run the timer. So for running the timer, the instruction is set bit timer run, and this is timer 1. So the instruction is set bit tr1. Next, what should be here? We should check the JNB. This is the part of delay. For this case, say I am writing this in a separate function, and this is say called, this is delay. This is the delay part. Now what is the delay part? For this delay part, what will happen? We should check whether the timer flag is high or not. So for this case, JNB jump if no bit timer flag 1, as we are using the timer 1, jump TF1 comma say here. Where will be this here? Here is here. Means until and unless the TF on timer flag 1 will be high, it will be here. So this is the main part for creating the delay. After this delay, we must make the timer off. So this will be timer off, clear T timer run 1. Timer run 1 means it will stop the timer. This is for stopping the timer. Next, what we should do? We should clear the timer flag as the flag became high, became logic 1 at this position. So we should clear it. CLR timer flag 1. This part, these three instructions, JNB TF1, clear TR1 and clear TF1. These three part, the 3-line instruction, this is for delay function. At the end of each subprogram, there must have a return instruction. When this return instruction will come, at that point, the program will or compiler will understand that the subprogram is finished. From here, it will move to here. For this delay will be called here. So a call delay means after running the timer, the delay will be called. It will come here. It will check whether the timer flag is logic 1 or logic 1 or not. Until and unless it is logic 0, means যদি এটা logic 0 থাকে তাহলে কি হবে, এখানেই থাকবে। কি হয়, the basic function কি হয়, this is the initial value. This is the initial value. What is the initial value of the timer? 0A12. What will happen when the timer is run? When the timer is run, then this value will be incremented by 1 as per the clock cycle. When one clock cycle will come, this will be 0A13. For next clock cycle, it will be 0A14 like this. So this will be incremented as per the clock cycle. This will reach the highest value. Highest value, what is the highest value? Highest value is the maximum value. This 4 bit will be F, next will be F, next will be F, next will be F. Means the highest value, this is the initial value, highest value always will be F. This is the highest value. This will be the highest value. Or so when the timer will start to run, the timer will be incremented by 1 and it will reach to the highest value. When this highest value will reach, next it will start from 0000H, and this time it is called normally rollover. Rollover means it will start again from 0, that is the initial value, not this one. This is we set this value, but normally the total range, this is the lower range value. So highest to, again it will start from 0. At this position, what will happen? At this position, timer flag will be high. So this is a particular situation. This status of the timer flag will be checked, and the checking is done by this instruction JNB TF1. Call the delay. The delay will be here. What will happen? Just it will check whether the timer flag is on or off. The timer flag will not logic 1, so it will remain here. For next cycle, the timer is incremented 1. Again, it is checked whether it is timer flag is high or not. It is not high, so it will remain here. So until and unless the timer flag will be logic 1, it will here. So this is the delay. Delay means program is not going to the down instruction. Program is not moving forward. So this is the delay. Mainly the timer is used for operating the delay instruction or there are so many other operation also, but one of the most important or very much used way is create the delay. So until and unless the timer flag is high, it will remain here. When timer flag is high, then it will move to the next instruction. So at this situation we must do something. Here say square wave will be generated. So what we will do, we will use the CPL. There are other way also, but here we are using the CPL. CPL pin is P1.3. So what is happening here, at this situation it was say logic 0. Timer started, came here, and timer reached to highest value. Next it clears the timer, timer flag is off. Again it returns to the this after this the instruction is jump say. So when this is completed means this return instruction, after this return instruction it will come here. So a delay is created here. And for the case of square wave generation, technical background is that for certain time duration, the port will be logic high, and for another time duration the port will be logic 0. So like this, say this is the square wave and it will continue like this. So from this to this is a particular situation, the timer will do nothing. So this is a delay, again this is a delay. So in this delay duration, say at this point this is logic low, next we will make the logic high, then it is high. For this duration this is high, again it will come to logic low and it will remain for this duration, it will again be logic high, it will remain for this duration. For a particular duration the pin will be logic low, and for a particular duration next the pin will be logic high. So this is happening continuously, then at that pin a square wave will be generated. So this is the program. So this is one logic level. So to repeat this again, what should be needed? Again we should reload the timer value. So short jump means from where we should go here at this position, because from here the timer is again reloaded. Some level should be given here, say repeat, and the repeat will be here. This is repeat. So this is our complete program to generate square wave at a particular point P 1.3. So this is the complete program. This first instruction, this instruction is required to set the timer in which mode the timer will act or timer will be used. Next two instruction is used for setting the initial value of the timer. CPL P1.3, this is the instruction for complement. Complement means when this instruction will be executed, it will be complement. Complement means say for a particular moment it was 0, next timer run holo, delay চলে এলো, ডিলে করার পর এই সমস্ত হলো, হয়ে আবার ফিরে যাওয়ার পর আবার নতুন করে টাইমার রিস্টার্ট হলো, রিস্টার্ট হয়ে পর আবার ওটা কমপ্লিমেন্ট হবে। কমপ্লিট মানে ইট উইল বি 1। নেক্সট আবার যখন লুপটা রান করবে ইট উইল বি 0। নেক্সট আবার যখন লুপটা রান করবে ইট উইল বি 1, লাইক দিস। So 1 0 1 0 1 0 at this pin P1.3 it will be 1 0 1 0 1 0 like this. So here it will generate a particular square wave at pin number P1.3. So this is the complete program for generating a square wave at pin number 1.3. So this is the first part. Write a program to create a square wave at pin 1.3. Next part, find the frequency of the generated square wave. Now we have to find the frequency of the generated square wave. We can find it by two ways. One way is considering all the instruction, and another way is considering only the main instruction. Main instruction means only the delay instruction. At this point say we are trying to find the frequency by considering all the instructions. All the instruction means আমার যে ডিলে প্রোগ্রাম স্টার্টস ফ্রম হেয়ার, আমি যেখান থেকে শুরু করি, ধরো একটা স্কোয়ার ওয়েভ, এটা 0 হয়েছিল, 0 হয়ে এই পর্যন্ত চললো, দিস ইনস্ট্রাকশন রান করলো, করতে করে আবার এখানে চলে এলো, করে এই পর্যন্ত এলো, আসার পরে ওটাকে চেঞ্জ হলো। তার মানে কি এখান থেকে আমার প্রোগ্রামটা শুরু হলো, স্কোয়ার ওয়েভের একটা পার্ট স্টার্টেড ফ্রম সিপিএল, it will continue from this to this and it will finish here. Next it will just reverse the situation. So from this move TH, from this to this return instruction, all the instructions are responsible to generate the delay program. Delay program means either at logic low state or logic high state. So for this case, to find out the frequency, we must require the machine cycle. For first instruction move TH1, 0NA, we need 2 machine cycle. Next, for this instruction we need 2 machine cycle. Next, CPL we need 1 machine cycle. Set bit timer 1, say timer 1 set bit, it requires 1 machine cycle. A call delay, this requires 2 machine cycle. Edge jump, this requires 2 machine cycle. JNB, this requires, আচ্ছা এটা পরে আসছি কারণ এটা কটা মেশিন সাইকেল দরকার এটা ক্যালকুলেট করতে হবে. নেক্সট ক্লিয়ার 1 মেশিন সাইকেল, this requires 1 machine cycle, this requires 2 machine cycle. So these are the machine cycle. এবার টি মোডের জন্য কিছু মেশিন সাইকেল নিশ্চয়ই দরকার, কিন্তু this will not affect, this is not inside the delay program or inside the square wave, কারণ এটা প্রথমে রান করা হয়ে গেল তারপরে আমার লুপের ভিতরে এটা নেই. So this is the machine cycle. Now only one is left, this one JNB TF1 comma here. Now how many machine cycle will be required for this? Say for running the JNB we need 1 machine cycle. In this case how many times it will run? TH1 and TL1, this is 0A12, this is the timer value. So this is the timer value, initial timer value. It will reach FFFF, then it will again roll over from 0. Total required cycle is the highest value FFFF minus of initial value. What is the initial value? Initial value is 0A12, this is the initial value, and for rollover it will be plus 1. So this is the total machine cycle required, 65535, that will be subtracted by 0A12. Now what will be value of this 0A12? 2578 plus it will be 1, 62958. This is the total loop. Loop means this loop JNB. So this 62957 times this will repeat. So what will be the total number of machine cycle? Now add this total machine cycle is 62972. For the delay portion means from this portion to this portion, total machine cycle required is that. Again from this to this, total machine cycle required. If we want to find out the frequency, we must need the time for this number of machine cycle, and that is the T by 2, basically T by 2. From this to this is total T, আর আমাদের যেটা বেরিয়েছে that is the delay is from this to this portion. So this to this portion is the half of the time. Basically this is the half of the time period. This is equal to 1 machine cycle requires 1.085 microsecond. So this will be multiplied by 2972 at a microsecond, 68324.62. This is the T by 2. So what will be T? T will be multiplied by 2,
136648.
So this is the total time period. This will be 0.136648 at a second. So this is the total time period. Frequency F will be 1 by T. What will be the value? 7.3180. What will be unit? যেহেতু এটা সেকেন্ড ছিল, unit will be hertz. So this is the frequency. Our last question ছিল find the frequency of the generated square wave. তাহলে আমি যে স্কয়ার ওয়েভটা জেনারেট হলো, this is the frequency, this is the last answer. যদি আমরা দেখি যে কোনটা ভুল আছে আমরা একটু কারেক্ট করে নেওয়ার চেষ্টা করব. According to this program, if we want to increase the delay, what modification we need?
Sir, আমরা যে ভ্যালুটা নিয়েছি না 0A12,
হ্যাঁ
এটাকে স্যার আমরা পিছিয়ে দিতে পারি।
পিছিয়ে মানে ভ্যালুটা কমাবো না বাড়াবো?
কমিয়ে দিতে পারি।
গুড, ঠিক আছে, কমিয়ে দিতে পারি। তাহলে আমার কোশ্চেনটা হচ্ছে টু গেট দ্য লার্জেস্ট টাইম ডিলে হোয়াট শুড বি দ্য ভ্যালু অফ টাইমার ওয়েন দ্য টাইমার ইজ ইউজিং মোড 1?
স্যার এটা 0000 হতে পারে।
হ্যাঁ ঠিক আছে। সো দ্য নেক্সট কোশ্চেন, সো রাইট এ প্রোগ্রাম টু ক্রিয়েট এ স্কয়ার ওয়েভ হ্যাভিং ফ্রিকোয়েন্সি 100 Hz at pin number 2.1. We should use the timer 0 in mode 0. What should be the program? We are producing the square wave, so the program will be like this, a similar program. Now what should be the modification? Here the frequency is given 100 hertz frequency is given, means this is the targeted output. We want to produce a square wave whose frequency should be 100 hertz. আচ্ছা এইটাকে চেঞ্জ করো, মোড 0 তো আমরা করছি না, আমরা মোড 1 করছি এই মুহূর্তে, মোড 0 তো হবেই না, কারণ আমরা হোয়াট এভার উই আর স্টাডিং অ্যাট প্রেজেন্ট সিচুয়েশন উই আর অলওয়েজ মোড 1. সো হোয়াট উইল বি দ্য ভ্যালু হিয়ার? TMOD should be 0 1. What should be the initial value? We must calculate it. So again we will come here how to calculate. So here it will be P 2.1. So total program will be like this. Total program will be like this. Making the easiest calculation, we are considering that, not considering overhead. ওভারহেড মানে হচ্ছে সমস্ত ইনস্ট্রাকশন কনসিডার করার দরকার নেই, শুধুমাত্র লুপের জন্য বেসিক্যালি জায়গাটা হচ্ছে এটা. তাহলে টু গেট দ্য 100 হার্টজ ফ্রিকোয়েন্সি, হোয়াট শুড বি দ্য ইনিশিয়াল ভ্যালু? আমরা এই যে ক্যালকুলেশনটা এখানে করেছিলাম, এবার আমরা উল্টো দিকে ক্যালকুলেশন করব. উল্টো দিকে ক্যালকুলেশন মিনস ফ্রিকোয়েন্সি f is equal to 100 হার্টজ. হোয়াট শুড বি দ্য টাইম পিরিয়ড? টাইম পিরিয়ড t will be 1 divided by f. কত হবে? 0.01 সেকেন্ড. So this is the total time period. Time period means from here to here, this is the total time period. Now to create the delay, half of the time period is required, কারণ এখান থেকে এইটুকু হচ্ছে একটা ডিলে, এখান থেকে এইটুকু হচ্ছে ডিলে. Delay is equal to half of this time period. So delay will be 0.005 এত সেকেন্ড. For generating the 100 hertz frequency, this is the delay period. What should be the initial value of the timer? Say initial value of the timer is y. So the highest value, that is f minus initial value y plus 1, this is the total machine cycle required, that will be multiplied by 1.085 microsecond. So into 10 to the power minus 6. This will be equal to 0.005. So this is the equation. কি বললাম, ধরে নিলাম initial value to y, because setting of initial value is the main thing. Initial value is y. So what is the equation? Final value minus initial value plus 1, that will be multiplied by 1.085 microsecond. This is ultimate equation. So from here, what will be the value of y? 65,535 minus y plus 1 is equal to 0.005 divided by 1.085. What will be the value? 0.004608 into 10 to the power 6. But this multiplied by 10 to the power 6 will come 4608. Therefore y is equal to 65,535 minus 4608 plus 1. What will be this value? 60928. So this is initial value in decimal. This should be converted to hex. Let me know the value in hex. EE00. So this is the value in hex. তাহলে বোঝা গেল যে আমার ইনিশিয়াল ভ্যালুটা কত হবে. এই ভ্যালুটা কোথায় বসাতে হবে? টাইমের ইনিশিয়াল ভ্যালু EEH002. ই এর আগে একটা 0 বসবে. দিস ইজ দ্য ফুল অ্যান্সার ফর দিস কোশ্চেন. আচ্ছা, এগুলো সব 0 হবে. টাইমারের এক এক জায়গায় সব 0 হবে.